Okay, so in this video I'm going to go through the forces level 3 questions. So these are the most difficult questions on forces. So the first question asks, explain what causes the weight of the metal block. Now you remember weight is due to gravity, so it's the gravity that's acting on a mass. And you've got the mass of a block and you've got the huge mass of the earth, and those two forces are equal, pulling on each other. So what's causing this? It's the mass of the block and the earth pulling with equal forces, and that force is gravity. Okay, so the force of gravity is equal, so the earth pulls on the block just like the block pulls on the earth. They pull on each other with equal forces. This is an example of Newton's third law. For every action and there's an equal and opposite reaction, so the forces are equal. Okay, so the next question says, what is the tension in the string when the block is lifted at a steady speed? Well, remember the word steady speed means constant speed, and constant speed means the forces are always balanced. If it's a constant speed, there's no acceleration. So we know if it's 4.5 newtons that way and it's a constant speed, it must be 4.5 newtons the other way. So both must be 4.5 newtons, okay? And the up force in this case is the tension, which is up here, okay? So it must be equal to 4.5 newtons. So the reason for that is because there is a steady speed, which is a constant speed, and if we have a constant speed, there is no acceleration, and the reason is because the forces are equal. Okay, calculate the work done lifting this load. So remember, work done, I'm just going to put a W, is equal to force times distance. The force is 4.5 newtons, and how far have we lifted it? A height of 90 centimeters. Remember, this must always be in meters, so it's 0.9 meters. We multiply those together, we get 4.05 joules. Okay, how much useful energy is transferred to do the work in part C? Okay, so the useful energy is going to be 4.05 joules. Okay, so the energy, remember, is transferred. So it's going to be transferred, and we're going to end up with the same value. To work out the power, we've got 250 joules, and it's taken 1 minute. So it's given us the equation, but you must learn this equation. It says work done over time, but remember, power is equal to energy over time, and work done is just the same as the energy. So we know from this part we've got 250 joules of energy, and we're going to divide that by 1 minute. There are 60 seconds in a minute, and it has to be in seconds. So 250 divided by 60 is 4.17, and that is in watts, which is a capital W. So remember, power is in watts. Okay, the next question. Use the words distance, force, and work to write an equation which shows the relationship between them. So again, work is equal to force times distance. What vertical distance up the rock face does Susan climb when she does 2,000 joules of work against gravity? Show your work and give your answer to the nearest 0.1 meters. So if work is equal to force times distance, and we're trying to find the distance, then we need to divide by force. So we divide by force on both sides. We can cancel that out. So distance is equal to work divided by force. So what we're going to do, well, we've got our work, which is in joules, and we have also got our force from the start of the question. Susan weighs 540 newtons. Okay, remember, weight is a force, it is in newtons. So if we do the division, we've got 2,000, and we're going to divide that by 540, and this will give us the distance, which is equal to 3.7 meters. How much gravitational energy will Susan gain when she does 2,000 joules of work against gravity? Well, it's going to be the same. Okay, remember all the energy is transferred from one form to another. Okay, the next question says the climbers dislodge a 3 kilogram stone which falls down the rock face. What is the speed of the stone? So the first thing is we've got an equation with speed and we need to rearrange this equation. So remember KE is equal to half mv squared. In this case they put speed squared, but it's the same thing as velocity squared. Well, we can say it's the same for this equation. So we need to rearrange this equation. So I'm going to do this down here. So the first thing is KE is equal to 1 times m times v squared, and we're going to divide that by 2 just to show how we're going to move this across. If we're dividing by 2, the opposite is to times by 2. So we're going to multiply this by 2, we're going to multiply this by 2. Dividing by 2 and timesing by 2 is just the same, so it's getting rid of the 2. Okay, the next one, we're 1 times m. Well, 1 times m is just the same as m, so we can now get rid of the 1. So now we're left with this. We're trying to get rid of the m, so we've got v squared, so if we're timesing by m, the opposite or inverse function is to divide by m, so we can now get rid of the m, so we're left with v squared. Remember that the opposite inverse function of squaring something is to do the square root of that, so that leaves us with v. So now we've got an equation that v, or speed, is equal to the square root of 2ke divided by m. And remember, we really need to do this first, so I'm going to put this in brackets. Okay, so let's look at what we've got. So it says, what is the speed of the stone when its kinetic energy is 600 joules? Well, the kinetic energy is 600, but it's 2 times 600. So we're going to put 2 times 600. And then we're going to divide that by the mass, and the mass is 3. Okay, so we're going to work the top bit out first, remember, which is 1200. We divide that by 3, and we will get 400. Okay. When we've done that, we're then going to square root 400. Remember, we're doing that last, which is why we put it in brackets. If we square root 400, the answer is going to be 20. And don't forget your units are in meters per second. Okay, so the next question says, the climbing rope is made of nylon. Nylon is very strong. Another advantage is that it stretches. This means that if Susan falls, it transfers some of her kinetic energy to elastic or strain energy at the end of the fall. Explain in terms of force and deceleration what would happen if Susan fell and the climbing rope did not transfer any of her kinetic energy to elastic energy. So basically it's saying if she fell down and the rope did not extend, well, as soon as she gets to that point, she's going to stop, and that stop's going to happen very, very quickly. If it doesn't stretch, then the time taken for her to stop is going to be very, very fast. Okay? So the deceleration being much, much quicker will mean that the force acting on her is very, very large. So why is that? Well, that's because force is equal to mass times acceleration. Her mass is not going to change. And we know that if we multiply from a previous video, that force is directly proportional to acceleration. So if Susan fell and the climbing rope did not transfer any of her kinetic energy to elastic energy, that means she's going to go from, say, 50 meters per second very quickly to 0 meters per second. That is a very fast acceleration. Because the elastic band isn't slowing down this deceleration, it's going to happen instantly, pretty much instantly. So that means the acceleration is going to be very, very large. So what are we doing with the acceleration? We are getting a very big acceleration, and because these are proportional, that means the force is also going to be great as well. Okay, so because force is proportional to acceleration, the force acting on Susan is very large because she decelerates very rapidly due to rope not extending. So if you imagine it's like traveling in a car, if you slam on the brakes, then you stop, but you stop quickly. If you put the brakes on gradually, you're going to slow down much more reasonably. If you just hit a wall in a car, then that could be dangerous because the change from a high speed to a low speed happens so quickly that it's very, very dangerous, and the force that acts on you is much greater. Okay, so that's the answer. Right, the next question, what is meant by the term resultant force? This is the sum of all forces, or the overall force. So when we take all the forces acting on an object and we add and subtract them, the overall force is the resultant force. Okay, describe the movement of the aircraft when the resultant force is 0. Well, if we have no resultant force, the object always travels at a constant speed, and it's better to say in a straight line. Always say in a straight line. So a constant speed in a straight line. Okay, the next question. The aircraft has a takeoff mass of 320,000 kilograms, and each of the 4 engines can produce a maximum force of 240,000 newtons. Remember, kilo means 1,000, so it's 240,000 newtons. So we've got 4 engines, and each of them is producing 240,000 newtons. And our mass is 320,000 kilograms. Now we know we can use our equation. You have to learn that force is equal to mass times acceleration. So A must be equal to force divided by mass. We know our force is 4 times this number, which is going to give us 960,000. And we're going to divide that by 320,000. If we do that, we're going to get our acceleration, which is 3. Okay, and remember, acceleration is in meters per second squared. Okay. As the aircraft moves along the runway to take off, its acceleration decreases even though the force from the engine is constant. Okay. So the reason for this is because of air resistance. So as the plane speeds up, the air resistance is going to increase. So as air resistance increases, the overall resultant force is going to be lower. Okay, so if we draw this in some arrows, the first arrow, we're going to start off when this plane starts moving. There's a big force from the engine, so we'll call this the engine force, and the air resistance is very low. But as it speeds up, the force on the engine is still the same, so it's still giving out the same power, but because the plane's speeding up, this force is getting greater. So you can see, if we have this example here, at the start, the resultant force might be something like that. Here, the resultant force might be something like that. So because the air resistance in, we'll call this number 1 and number 2, because the air resistance in number 2 has increased, the resultant force has decreased. The overall, the overall force as I described up there, or the sum of all the forces. Okay, so what's the answer? As air resistance, we'll just call it AR, increases, the overall resultant force will decrease. Okay, right, the next question. So the diagram shows a plank being used as a simple machine, and the crate is slid up the plank onto the back of the lorry. Okay, the mass of the crate is 70 kilograms. Calculate the weight of the crate. So we know that weight is equal to mass times gravity. If we've not been given it, on your exam you will be given in the question gravity. So I'm just going to calculate it for both just to give you an example. So we know that 70 times by 10 is going to give us 700, or it could be 70 times 9.8, and that will give you 686, and both are in newtons because they're a weight. Okay, so if we use gravity as 10, we will get 700. If we use gravity as 9.8, we get 686. The work done, remember, is equal to force times distance. We've just worked out our force. We're going to say 700 because it's easier to use. We've multiplied it by the distance, which is 0.5, and that's going to give us 350 joules. Okay, so a roller coaster stops above a vertical drop and then suddenly falls under gravity. Again, we're after the force here, okay? So we know that force is equal to mass times acceleration, so we need to find these points. The acceleration experienced by the people is 10, and the mass is 1210, so we know that that's 1210, and we're going to multiply that by 10, and that will give us 12,100 newtons. Okay, this last question is about a vector diagram. So we need to understand how to do a tip-to-tail diagram, which I showed you in the video that goes with these exam questions. So the first thing is we need to work out a scale. So it says the resultant vertical force, okay, so this is a force that is acting either up or down, and because it's a vertical force of 300 newtons on the SkyDriver, I'm just going to assume that the vertical force is the weight. Okay, so we're going to say that's 300 newtons. Now we need to decide a scale. So because it's 300 newtons, we should have enough that if one box represents 50 newtons. Okay, so that would mean one little square is equal to 5 newtons. So if I draw this vertical force, if one box is 50, then we're going to go 2 to 100, 3 to 150, 4 to 200, 5, 6. You have to do this with a ruler. So make sure in your exam you have a pencil and a ruler so you can rub it out if you make a mistake. So if one box is 50, then 6 times 50 is going to be equal to 300, which is what we've done. We've done 6 boxes. There is a horizontal force from the wind of 60 newtons. Well, we know that 1, so we're going to draw our arrowhead. That is our vertical. Okay, and then we put the tip on the tail there. One box is going to be equal to 50, and we know each square is worth 5, so we're going to continue that on to there, and that is our arrow. Okay, so we've now drawn the 2 vectors in our diagram. We need to connect them, so I'm going to do this in a different color just to illustrate our resultant force. Okay, now you have to make sure that this is exactly on that line. It's hard to draw it without a pencil and a ruler, so when you're doing that, make sure yours is very accurate, okay, because you might need to measure the angle, and you can see from the very start to where we finish, that is our vector, and you would need to measure that line. It must be drawn with a ruler. But because I haven't drawn a ruler, I'm just going to use a bit of Pythagoras to work this out. So we know that this is equal to 300. We know that this is equal to 60. And I can now work out the hypotenuse of the triangle by using Pythagoras. We know that c squared is equal to b squared plus a squared, or a squared plus b squared, whichever way around you want to use it. So we know that that's equal to 60 squared plus 300 squared. Now, 60 squared is going to give you 3,600. We're going to add that to 300 squared, which is 90,000. If we add those two things together, we're going to get 93,000, and that is 600. So c squared is equal to this. So to work out c, we're going to have to square root 93,600, and that will give us 305.9. So our force is 305.9. That means that this line, if you did it with a ruler, if you measured that with a ruler, that with a ruler, and you did it from the exact start to the exact finish, when you measure this with a ruler, you should get 305.9. Okay, now how would you work that out? Well, you'd have to do it to a scale. So you'd have to work out, well, how many squares is that worth? Work it out with a ruler and then work that out. This is why I've used Pythagoras. It's just a little bit easier, and you can get an exact figure by doing the maths.